Good evening. Is it audible? Okay, good. So today class is very, very important. Signal flow graphs. Either block diagrams you understood or not a problem. But signal flow graph should be perfect. Day 3 PDF not yet sender. Oh, I lost that fellow. Day 4, 5, they sent it already. Last day video, last day PDF. They uploaded, na? Okay, I'll talk it about November 15th. I'll talk with the manager. I made it again PDF. I sent to the manager also. Last day PDF also I sent to the manager. We are having all the PDFs, all the days PDFs we are having. Even last day PDF also I made it. Day 3, day 4 are same in portal. Check it. Day 3, day 4. Okay. Okay. Last one also I send it. Okay. Last one I already uploaded to that fellow. I sent to the manager. He will upload to you. Okay. You check it. Day 3, day 4. There may be a printing mistake. Instead of day 3, there may be day 4. You check it. Okay. Right. We'll start the subject. So last 15 minutes we'll discuss the volume 1, volume 2 questions. First we'll start the subject. Listen carefully. Today very important. Signal flow graphs are very, very important. Either block diagrams you understood or not a problem. If you are perfect in signal flow graph, you can answer. Okay. But still you practice block diagram problems also last day. Whatever we discussed in the class. Whenever they give a block diagram, which you are able to simplify without shifting operation, in case shifting operation not required, then we can solve by using the block diagram reduction techniques. Okay. Right. Signal flow graph. Note on the problem. Delayed already because of some page adjustment. They changed the page numbers. Control previously 6th page was there. Now it is shifted to another page. That's why it is a little bit delayed. Okay, right? Construct the signal flow graph. Note on the problem. Listen carefully. Construct the signal flow graph to the given linear algebraic equations. Linear algebraic equations. Linear algebraic equations. Y2 equal to Y1 plus 2Y3. Y3 equal to 3Y1. 3Y2 you take. 3Y2 plus 4Y4. Y4 equal to 5Y3 plus 6Y4. 6Y4 plus 7Y5. Y5 equal to 8Y4 plus 9Y2. Y6 equal to 1Y5. Come on, draw the signal flow graph. Draw the signal flow graph to the given set of linear algebraic equations. I am uploading every day. Once class is completed, I am sending to the managers. Once class completed, immediately I'll send the manager to this PDF so that they will upload. I'll inform to him. Day 3 is not uploaded. I will inform to that fellow. Okay. Right. But be regular to the class. Many students are joining late. Tomorrow onwards, I'll start. Tomorrow, no class, I think. Saturday. After tomorrow, we'll start exactly 6 or most case 6:05. Come on, total how many notes are required here? Today I'll discuss all the problems. No need to worry. Chapter 1, everything I'll discuss. So how many nodes are required? Total 6 nodes. Number of nodes equal to number of variables. Total 6 variables, 6 nodes. Come on, select it. 6 nodes you select. Y1, Y2, Y3, Y4, Y5, Y6, 6 nodes. So now take right side is input nodes, left side is output node. Right is input, left is output. The branch start at Y1, end at Y2. What is the path gain here? Nothing is there means 1. The branch start at Y1, end at Y2. What is the path gain? 1. Next, start at Y3, end at Y2. What is the path gain? 2. Start at Y3, end at Y2. What is the path gain? Tell 2. Path gain is 2. Next, first equation completed. Yes. Okay, first equation completed. Next, second equation. Start at Y2, end at what? Y3. Start at Y2, end at Y3. What is the path gain? Tell 3. Path gain is 3. Next, start at Y4, end at Y3. Start at Y4, end at Y3. What is the path gain? Tell 4. The path gain is 4. Next, start at Y3, end at Y4. What is the path gain? Start at Y3, end at Y4. What is the path gain? 5. The path gain is 5. Next, start at Y4, end at Y4 only. Self loop. Start at Y4, end at Y4. What is the path gain? 6. This direction you may give like this also. Any direction. Self loop may be any direction. It may be any direction. Self loop. Next, start at Y5, end at Y4. What is the path gain? Tell 7. Path gain is 7. Path gain 7. Next, fourth equation. So this complete and start at Y5, end at Y4, path gain 7. Next, start at Y4, end at Y5. What is the path gain? 8. Start at Y4, Y4 started, end at Y5, path gain is 8. Next, start at Y2 here, end at Y5. This is Y5. What is the path gain? 8. Path gain is 8. Path gain 8. Next, start at Y5, end at Y6. What is the path gain? 1. This is a complete signal flow graph. It is a complete signal flow graph. So like this, you have to draw the signal flow graph to the given linear algebraic equations. Okay. So you have to construct the signal flow graph like this. Okay, na? Next, second bit, B bit. Second bit. I hope completed. Second bit. Second bit. Right. Second bit. Find the number of forward paths. Find the number of forward paths. Individual loops. Individual loops. And two non-touching loops. Two non-touching loops to the above signal flow graph. Two non-touching loops. Two non-touching loops to the above signal flow graph. To the above SFG. Come on, find it. To this only. To this only. So how many forward paths are there? Come on, how many forward paths? Come on. How many forward paths? Anybody? Two forward paths. Very good. How many loops? Number of loops. Ah, 9/2, correct. This is 9. This is 9. 9/2, correct. Come on. How many forward paths? Tell. This is one forward path. This is straight. Straight is one forward path. What is the definition of forward path? It is a path from input to output. So it is a path from input to output, but along the path, each node should be touches only once. Along the path, each node should be touches only once. So this is one forward path. The second forward path is like this. The second forward path is like this, going to this and through 9 like this. This second forward path. Some students, they used to take like this. 1, 3, 5, 6, again come back. The third forward path they'll take. It is wrong. Why? Because while going this, Y1 touched, Y2 touched, Y3 touched, Y4 touched, again through 6, Y4 second time touching. The correct forward path is the one each node should be touches only once. The correct forward path is the one each node should be touches only once. So first statement is what? What is the first statement? The correct forward path is the one each node should be touches only once. The correct forward path is the one in which each node should be touches only once. In which each node should be touches only once. Should be touches only once. Forward path means path from input to output. Forward path means what is a forward path? It is a path from input to output. But along the path, each node should be touches only once. It is the path. It is the path from input to output. Input to output. What is the loop? Tell. What is the loop? Loop is a path. It terminates at the output. Loop is the path. Loop is the path. It terminates. It terminates where it is started. It terminates where it is started. Terminates at where it is started. Loop is a path. It terminates at where it is started. Starting point, ending point, same. Where it is started. Where it is started. Where it is started. Next, non-touching loops. What is the non-touching loops? Non-touching loops. Non-touching loops means if there is no common node, if there is no common node, between two or more loops, between two or more loops, then it is called non-touching loops. Then it is called non-touching loops. Then it is called non-touching loops. If there is no common node between two or more loops, then it is called non-touching loops. Next, input node. What is the input node? Anybody? The node, it has only outgoing branch. The node, it has only outgoing branch. Only outgoing branch. The node, it has only outgoing branch. Output node. What is the output node? The node, it has only incoming branch. The node, it has only incoming branch. Only incoming branch. What is the chain and link node? Link node or chain node. Link node or chain node. It has both incoming and outgoing branches. It has both incoming and outgoing branches. It has both incoming and outgoing branches. Now tell how many forward paths here? 2 forward paths. We are having 2 forward paths. 2 forward paths. 2 forward paths. Okay, 2 forward paths only. Next, number of loops. Anybody correct answer? Number of loops. Number of loops. 5. Some people written now 9. Here 9 Y2 na. 9 Y2 start at Y2, end at Y5. The path gain of 9. Okay, 9 Y2 start at what? Y2, end at Y5, path gain 9. Next, how many loops? Total number of loops. Nobody telling correct answer. Number of loops. 5, 1, 3. Individual loops. Individual loops. Anybody correct answer? Okay, listen. I'll write the loops. Correct. 5 is correct. I think 5 is correct. Listen, individual loops. Very good. Listen. Listen here. So first select the feedback path. What is the feedback path? 2. Feedback path is selected 2. To this feedback path, how many forward paths are there? started at y3, end at y2. How many forward paths here? There is only one forward path like this. That means it is only one loop. That is L1. That is L1. Select the just feedback path. Feedback path 2, having only one forward path. That means L1. Similarly, select the second feedback path. This is the second feedback path. How many forward paths are there from Y3? Second feedback path started at Y4, end at Y3. Y3 to Y4, how many forward paths? Only one. That is what? L2, second loop. Next, select third feedback path. Third feedback path, where it is started? Y5. Where it end? Y4. Y4 to Y5, how many forward paths? Only one. That is what? L3. So this is L3. In case there is another path like this, then it will become a what? Two loops. But here only one forward path, L3. Next, this is the self loop. Self loop becomes the what? L4. Self loop becomes L4. Self loop is L4. Next, whenever many feedback paths are connected like this, whenever many feedback paths are cascaded like this, it is cascaded, not the feedback paths are cascaded, and having a separate forward path, that will also act as a loop. That is L5. Whenever many feedback paths are cascaded and having a separate forward path, that will also one loop. That means L5. So total how many loops are there here? 5 loops are there. This is L1. This is L1, like this L1, like this L2, like this L3. This is L4, and this is L5, like this. This is L5. So total 5 loops are there. Very good. Many students are told correct answer. There are 5 loops. Next one. How many 2 non-touching loops? 2 non-touching loops. Now see, for 2 non-touching loops, you follow a proper order. Listen here. For 2 non-touching loops, follow a proper order. Listen. 2 non-touches. So 5 individual loops. 5 individual loops. 5 individual loops. Next, 2 non-touching loops. 2 non-touching loops. 2 non-touching loops. How to find 2 non-touching loop? Mean take L1, compare with L2, L3, L4, L5. Next, take L2, compare with L3. Next, higher number, L4, L5. Next, take L3, compare with L4, L5. Next, take L4, compare with L5. You go in a proper order, so that you will get the correct number of 2 non-touching loops. You go in a proper order. L1 select. For example, take L1. This is L1. Compare remain all. L1, L2 touching. L1, L3 non-touching. L1, L4 non-touching. That means L1, L2 touching. L1, L3 non-touching. L1, L4 non-touching. What about L1, L5? This is L1. L5 is like this, na? That means L5 is touches. Yes or no? L5 touches all, because L5 is combination of all the feedback paths. So L5 touches with L1. So that means L5 is touches with L1. So now L1 completed. Next, take L2. Next, take L2. For example, L2 you take. Take the L2. Compare remain higher number only. Don't go for lower number. L2 with L3 touching. L2 with L4 touching. L2 with L5 also touching. L5 same feedback path, na? L5 also touching. That means L2 touching with L3, L4, L5. Next again what? Next what I have to do? L3. Next select L3. So this is L3. Next select L3. L3 touching with what? L4 as well as L5. So that means it is touching with L4 as well as L5. Yes or no? L4. This is L3. L4 how it is? This is L4. For both the thing, common node this one, this is L3, this is L4. Common node is this. So that means touching. L5 is same feedback path. So L5 also touching. Next L4, L5. L4, L5 also touching. This is L4. This is L5. L5 like this. So that means at this no touching na. So that means what happened? L4, L5 also touching. That means how many two non-touching loops? Two non-touching loops. Two non-touching loops. Okay, na? So like this, you have to get the forward paths, individual loops, and two non-touching loops. Next, one more problem. Okay, one more problem. ఏం లేదు వెంకరెడ్డి, అది పేజ్ నెంబర్ చేంజ్ అయింది కదా. ఇంతకుముందు 6th పేజ్ ఉండే, అది పేజ్ నెంబర్ చేంజ్ అయింది కదా, 6th పేజ్లో లేదు ఇప్పుడు. అదే దాని గురించి చేసేది. సరే రైట్. నెక్స్ట్ ప్రాబ్లం. Repeat, not on problem. Find the number of forward paths, individual loops, two non-touching loop and three non-touching loops. Find the number of forward paths. Find the number of forward paths. Individual loops. Individual loops, two non-touching loops, and three non-touching loops to the given signal flow graph. To the given SFG. Come on, draw it, all of you. You also draw it and tell the answer. Come on, do it. You should do R of S, X1, X2, X3, X4, 1, C of S. A, B, C, D, E, F, G. H, I. Come on, do it. Come on, Bhaiya. Come on, jaldi karo. Very good. Come on, tell the answer. Anybody? Number of forward paths, 3. Very good. Forward paths 3. Next, individual loops, 6 loops. 7 loops. 7 loops, 3 forward paths. 7 loops. Very good. So here listen, all of you. How many forward paths? 3. Check it, all of you. One forward path straight, like this, ABE. Forward paths. Forward paths. First P1 is ABE, or X1, X2, X3, X4 is the first forward path. Second forward path is, what is the path gain means here? ABE. Second forward path X1, same thing, X2, X3, X4 only. But through this X1, X2, through C. Through C, second forward path. Second forward path is through C, like this. Through C, like this. This is the second forward path. So ACE. Second forward path is ACE. ACE. Third forward path is F. Third forward path simply X1 to X4. Path gain is F. This is the third forward path. Next, individual loops. Next, individual loops. Individual loops. Individual loops. Come on, how many loops are there? First, select the feedback path D, for example. First, select this feedback path D. To the D, where it started X3, where it end X2. X2 to X3, how many forward paths? One forward path B, one forward path C. So that means the feedback path D, having, where it started, first of all, it started at node X3, end at node X2. Node X2, started X3, end at X2. X2 to X3, how many forward paths we are having? X2 to X3, one is B, one is C. That means 2 forward paths. 2 forward paths. For means forward paths. That means 2 forward paths means it gives the 2 loops. It gives the 2 loops. 2L means 2 loops. 2 loops. So what is that? Loop 1 is, loop 1 below B and D. Yes or no? So B, D. BD. What are the node numbers? X2, X3. Node numbers is X2, X3. Again X3 to X2. Next loop 2 is CD. Loop 2 is CD. What are the node numbers? X2, X3. X2, X3. Next again. Next go for the second one. Second feedback path what? G. This is the second feedback path. So to the second feedback path G, where it is started X4. Where it end, this is the standard procedure. X4, where it end X1. X1 to X4, how many forward paths? X1 to X4. X1 to X4, how many forward paths? So one forward path ABE, second forward path ACE, third forward path F. That means 3 forward paths. 3 forward paths means it gives 3 loops. You have to see only that feedback path where it started, where it end. Between the 2 nodes only we have to observe how many forward paths, how many forward paths are there. Feedback path G started at X4, end at X1. X1 to X4, how many forward paths? One is straight, one is through AC, third one is F3 loops. So what are the 3 loops? L3. What is L3? Tell. A, B, E, G. A, B is G. Node numbers X1, X2, X3, X4. Node numbers X1, X2, X3, X4. Next, loop 4. What is the loop 4 tell? A, if you go along this path gains, automatically you will get the loop. A, C, E, G. A, C, E, G. What are the node numbers? X1, X2, X3, X4. Next, third loop. What is the third loop? FG. So like this. This is F and then this is G. This is the third loop. So FG. What are the node numbers? X1, comma, X4. Next. So that means this is given L1, L2. This is given L1, L2. Second feedback path given L3, L4, L5. And this self loop is L6. This self loop is L7. Total 7 loops. The feedback path H. The feedback path H. Given a self loop H. It start at X1, end at X1 only the self loop. So that means one loop. That is what? L6. Path gain is H. Node number is X1. Next self loop I started at X4. It is a self loop. It is a self loop. That means it is a one loop. One loop. That is what? L7. Path gain is bolo I node number X4. So total how many individual loops? 7. 7 individual loops. Individual loops are 7. 7 individual loops. I hope you got it. I hope you got 7 individual loops. Next, 2 non-touching loops. 2 non-touching loops. How many 2 non-touching loops are there? 2 non-touching loops. How many 2 non-touching loops are there? So for 2 non-touching loops, select L1 and compare remain all the loops. Select L1, compare remain all. So for example, select L1, compare with L2, L3, L4, L5, L6, L7. Same node is there touching. If same node number, single node number is same, then it is touching. L1, X2, X3. Here also X2, X3. That means L1, L2 touching. X2, X3. Here also X2, X3. That means L1, L3 touching. Here X2. First I selected L1, X2, X3. I compared with L2 touching. I compare with L3 touching. I compare with L4 touching. Here also X2, X3 is there. I compared with L5 non-touching because here X2, X3, here X1, X4. That means L1 non-touching with what? L5. L1 non-touching with L5 and L1 non-touching with L6 also because here X1, here X2, X3. That means non-touching with L6. Even L7 also non-touching because here X4. So L7 also non-touching. That means L1, L5 non-touching, L1, L6 non-touching, L1, L7 also non-touching. But in the GATE exam till now, generally they will ask they don't ask like this big problem. Simple problems only they will ask. Even if you ask for 1 mark, generally forward paths and individual loops they used to ask. For 2 marks, they used to ask it. Individual loops and 2 non-touching loops, they used to ask it. Individual and 2 non-touching loops. So next, L1 completed. Now selected L2. You select L2. Don't go back. Don't compare L2 with L1. Compare L2 with next higher number only. L2 with L3, X2, X3, X2, X3 touching, X2, X3 touching, X1, X4 non-touching. That means L2 with L5 non-touching. Next with L6 also non-touching because here X1, here X2, X3 is there. That means L2 with L6 also non-touching. Next L2 with L7 also non-touching because here X4, here X2, X3. L7 also non-touching. So next L2 also completed. You have to compare till the last loop. Next L3, X1, X2, X3, X4. Here same number touching. Here X1 same, X4 also same touching. Here X1 same, X4 same, so touching. That means it is touching with all the loops. Here L4 also X1, X2, X4. Touching with L5, touching with L6, touching. Also touching with all the loops. Next L5. L5 select X1, X4, X1, X4, touching with both the loops. L6. L6, what happened? It is touching or non-touching? Non-touching with L7. So that means total how many tell? 1, 2, 3, 4, 5, 6, 7. There are 7 2 non-touching loops. There are 7 2 non-touching loops. 7 2 non-touching loops are there. Total 7 2 non-touching loops. 7 individual loops, 7 2 non-touching loops. Next 3 non-touching loops. Next 3 non-touching loops. Generally till now, they didn't ask 3 non-touching loops. Maximum 2 non-touching only. Because unless until find 2 non-touching loops, you cannot find 3 non-touching. If simple problem, directly we can identify. If it is a simple problem, directly we can identify. Okay. So 3 non-touching loops. Now come on. How to find 3 non-touching loop means you have to select the pair of 2 non-touching loops. You can identify this. There are 3 non-touching loops are there. By the procedure means select the pair of 2 non-touching loops. Pair is what? L1, L5. So what are the node numbers for L1, L5? L1 node is what? X2, X3. X2, X3. L1 node is X2, X3. L5, X1, X4. So X1, X4. So now what is the combination? L1, L5 means X1, X2, X3, X4. X1, X2, X3, X4. Compare with remain all the individual loops. X2, X3, X2, X3 touching, X2, X3, X2, X3. All are touches because it is a combination of all the nodes. All are touches. That means with L1 and L5, 3 non-touching loops are not possible. Next one. Next L1, L5 completed. Next select L2 and L5. Next, sorry, L1 and L6. Here L1 and L6. What is L1 tell? X2, X3. What is L6 tell? L6 is what? X1. Now compare X1, X2, X3, which is non-touching with what? X2, X3 touching, X2, X3 touching, X2, X3 touching, X1 here touching, here X1 touching. But it non-touching with what? L7. Non-touching with L7. So what is the one non-touching loop? L1, L6, L7. One combination is L1, L6, L7. L1 ante this one, L6, L7. Next L1, L6 completed. Next L1, L7. L1, L7. So X2, X3. L7 is what? X4. X4. Now observe X2, X3, X4. X2, X3 touching, X2, X3 touching. Here what is touching? X4 touching. Here X1 non-touching. That means L6. So but these two are same. L1, L6, L7, L1, L6, L7. These two are same only one loop. It is considered as one loop because both are having a same number, same loops, L1, L6, L7. It is considered treated as only one loop. Next, similarly, next take L2, L5. L2, L5. What are the loops? L2, L5 means X2, X3. L5 means X1, X4. It is touches with all because it is a combination of all the nodes. Next, L2, L6. L2, L6 means X2, X3 with X1. Again, it is touches non-touching with all, X2, X3. L1 touching, L2 touching, L3, L4, L5, L6 also touching, L7 non-touching. So that means what happened? L2, L6, L7. Again, one more L2, L7. L2, L7 means what? X2, X3 and L7 is what? X4. Again, it is touching with what? All it is touching except what? L6. x2, x3, touching, 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 touching. But here non-touching with what? L6, x1 not there, L6. But these two combinations are same. This two is same. L2, L6, L7, L2, L6, L7. Next again, L6, L7, L6, L7. L6 is x1, x1. L7 is x4. Non-touching with what? x1, x4. Non-touching with L1, non-touching with L2. Again, it is same combination. L1, L6, L7, and here also L6, L7 only, na? So that means what? L2, L6, L7, same combination. This is what? This one, and this is this. That means total how many? 3 non-touching loops? 3 non-touching loops are 2. 3 non-touching loops. So like this by the procedure. But here by looking we can identify L1, L6, L7, L2, L6, L7. 2 non-touching loops are 2. By this is the procedure. But till now, but you should be perfect in identification of individual loops, 2 non-touching loops and 3 non-touching loops. Then only you can write the correct answer. You should be perfect in identification of loops. Then only you can write the correct answer. Okay, na? So practice the loops. Okay. Individual, 2 non-touching, 3 non-touching you practice. Okay, na? I hope you understood. Next problem. Homework problem. I'll give one problem homework. You solve it. Okay, na? You practice it. Next problem. Homework. Repeat the above problem. You also draw it. Simultaneously draw it. Right. Homework you solve. I'll tell the answers tomorrow. Okay. Next, I hope completed. Next, Mason's gain formula. Mason's gain formula. Mason's gain formula. Mason's gain. What is the purpose of Mason's gain formula? To find the overall transfer function of the system. To find the overall transfer function of the system. To find the purpose. To find the overall transfer function of the system. To find the overall transfer function of the system. Overall transfer function of the system. What is the formula tell? Overall transfer function equal to sum of Pk delta k by delta. Pk delta k by delta, where k equal to 1 to I. Where k equal to 1 to I. Where k equal to 1 to I. And one more thing, what is Pk? Where Pk is kth forward path gain. Where Pk is kth forward path gain. Kth forward path gain. Kth forward path gain. Where Pk is kth forward path gain. Next, delta. What is delta tell? 1 minus sum of individual loop gains. Individual loop gains. Individual loop gains plus sum of gain products of two non-touching loop gains. Two non-touching loop gains. Two non-touching loop gains minus sum of gain products of three non-touching loop gains. Three non-touching loop gains. Bolo. Plus sum of and so on. Gain. This is products. Product of four non-touching loop gains. Four non-touching loop gains and so on. So this is what? Delta. Delta is 1 minus sum of individual loop gains plus sum of gain products of two non-touching loop gains minus sum of gain products of three non-touching plus sum of gain products of four non-touching loop gains and so on. Next, delta K. What is delta K? Delta K. Delta K is obtained from, it is obtained from delta. It is obtained from delta. It is obtained from delta by removing the loops touching with kth forward path. By removing the loops touching with kth forward path. Touching with kth forward path. Kth forward path. Whatever the loops touches for that forward path, all that removed, then you have to write the delta K. Delta K is obtained from delta by removing the loops touching the kth forward path. Touching the kth forward path. Touching the kth forward path. I'll take one problem. I'll explain so that you can understand. I'll take one problem. I'll explain. Okay, so that you can understand. So next, note on the problem. I hope completed. Note on the problem. Okay. Right. Note on the problem. Find the overall transfer function. Find overall transfer function. Overall transfer function to the given SFG, to the given signal flow graph, to the given signal flow graph. So come on. You also draw it and solve before me. You should solve before me, man. Who knows, you solve it. Who don't know, listen carefully. Try to understand the concept. First, I'll explain by the procedure. Then I'll tell the shortcut procedure, how to write directly answer. You should be able to write directly. Yeah. You should learn it, how to write directly. Come on, solve it. Come on, tell the answer. First, first go by procedure. First go by procedure. How many forward paths? Come on. Mason's gain formula in the SFG only, na? SFG means signal flow graph. Limitations of SFG means it is valid for only linear systems. We can say that is the one limitation. Another thing is that signal flow graph gives the transfer function between input to input node and output node only. That is also one limitation. Okay, na? Right, next. Come on, write the forward path. First forward path. I hope you solved it. Who knows? Listen. Forward paths. How many forward paths? 2 forward paths. One is along the straight. Second one through G5. Yes or no? So P1. P1 is G1, G2, G3, G4. If you have any doubt, go along this path gains. Next P2. P2 is G5. Second forward path is G5. Second forward path G5. Next loops. Next go for loops. 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 So loops. Come on. By using Mason's gain formula only, we'll write the transfer function. Yeah, SFG means signal flow graph. Some students they written what is SFG. SFG means signal flow graph. Yeah, listen. Come on. Loops. How many loops are there here? Total 3 loops. This is L1. This is L2. This is L3. There are 3 loops are there. Come on, write all the 3 loops. L1 minus H1, L2 minus, see, what is L2? G3 and minus H2. That means minus G3H2. Next L3. L3 is minus G4H3. Minus G4H3. Minus G4H3. This is L3. Okay. Next, two non-touching loops. Next we'll go for two non-touching loops. How many two non-touching loops are there? Two non-touching loops. Two non-touching. L1, L2 non-touching. L1, L2 non-touching. L1, L2 non-touching. What is the path gain? Tell here minus, here minus. Minus, minus become plus. That means what I will get? G3, H1, H2. Next, L1, L3 also non-touching. Go in order. L1, L2 non-touching. L1, L3 non-touching. L1, L3 also non-touching. What is the path gain? Minus, minus become plus. That means G4, H1, H3. So L1, L2 completed, L1, L3. Next, L2, L3 touching. L2, L3 is touching. So this is two non-touching loop. That's all. Is there any more loop? There is no more loops. Now write the transfer function. First write the delta. Now write the delta. What is delta? Tell. Delta equal to 1 minus individual loop gains. That is L1 plus L2 plus L3. Individual loop, 3 loops now, L1, L2, L3. Plus 2 non-touching loop gains. What are that? L1, L2 plus L1, L3. This is called delta. This is called delta. Next, delta K. Delta K. Delta K is obtained from delta only. So now delta 1, for example. Delta 1. Delta 1. Delta 1 is obtained from delta only. It is obtained from delta by removing. It is obtained from delta by removing the loops touching first forward path. To the first forward path, whatever the loops touching, that you have to remove. To the first forward path, whatever the loops touching, that we have to remove. To the first forward path, what are the loops touching? Tell. Bolo. To the first forward path, L1 here touching. This is the first forward path na, along the straight na, G1, G2, G3, G4. So L1 touching, remove it. L2 touching, remove it. L3 touching, remove it. That means L1 remove, L2 remove, L3 remove. Wherever L1, L2, L3 is there, remove. Here also L1, L2 is there, here L1 is there, remove it. That means what is left? 1. So delta 1 equal to 1. Delta 1 equal to 1. Even single term is there, the total term should be removed. Okay, that product term should be removed. Similarly, next delta 2. Find delta 2. Next, find delta 2. Delta 2 also obtained from delta only by removing the loops which are touching to second forward path. Delta 2 obtained from delta by removing the loops touching the second forward path. This is the second forward path. This is the second forward path. This is the second forward path. To this, what are the loops touching? Tell. Only L3 touching here. Here L3 touching. But L1 non-touching. L2 non-touching. That means only L3 removed. Here L3 is there. Remove it. Here L3 is there. Remove it. Here also L3 is there. Remove. Here L1 not removed because non-touching. L2 non-touching. Not removed. L3 touching. Remove. L1, L2 non-touching. And here this is what? L3 removed. Now tell what is delta 2? Tell. 1 minus, come on, L1 plus L2 plus L1 L2. L1 plus L2 plus L1 L2 plus L1 L2. So this is what delta 2. Now write the transfer function. Now write the transfer function. Now write the transfer function. What is the transfer function? Overall transfer function equal to bolo P1 delta 1, 2 forward paths na. P1 delta 1, P2 delta 2 divided by delta. There come on, substitute it. P1 delta 1, P2 delta 2, substitute all the terms, then you will get the answer. Come on, P1. Write it, P1. What is P1? G1, G2, G3, G4, P1 into delta 1, 1 plus P2. What is P2? G5 into delta 2. What is delta 2? 1 minus of L1. What is L1? Minus H1. Minus become plus. That means 1 plus H1. Yes or no? Here minus L1. Here what happened? L1 is minus H1. Minus become plus. Next, minus of L2. Here minus sign is there. Minus become plus. That means G3H2. G3H2 plus. Next, L1, L2. L1, L2 is what? G3, H1, H2. G3, H1, H2. H1, H2. Okay, divided by delta. Divided by delta. What is delta tell? 1. Here is there na delta. This is delta. 1 substitute L1, L2, L3 values. 1 opposite sign of L1. That here minus L1 na. Here minus means it become plus. So 1 plus H1. Similarly minus L2 means here plus. That means G3H2. Similarly again L3 minus sign is there. Here minus plus. So G4 bolo H3. G4 H3. Next plus L1 L2. Here positive. Here also positive. So positive only. Plus G3 H1 H2. G3 H1 come on H2. Plus again what happened? L1 L3 means what? G4 H1 H3. That's all. It is the answer. It is the overall transfer function. It is the overall transfer function. I hope you got it. Got it na? Any doubt? Got it na? This is by the procedure. But simple shortcut. How to simple shortcut I will tell. Okay, simple shortcut. Listen bhaiya. I hope you got it na? Simple shortcut. Right, listen. This is 7F. 8F I just copied here. So I'll remove this. So this is clear na? This is clear na? Now I'll explain the shortcut. No need to go by this procedure. Directly we can answer. Listen. I'll explain the simple shortcut. Okay. Right. Listen. How to write directly? Listen, bhaiya. How to write? This is very, very important. The objective in the exam you have to write answer like this only. I'll go by like this step-by-step procedure means they'll ask for 1 mark, maximum 2 marks. They don't give additional sound. They'll give it, not additional rough work they'll give, but still you can save the time now if you write directly. So listen. First step, listen bhaiya. First step, you identify the number of forward paths. First step, identify the forward paths. Next, loops. You have to identify the loops. Forward paths, loops. First for loops, mainly important loops. Once you identify the loops and forward paths, then write the answer. C of S by R of S equal to listen all of you. Listen bhaiya. First select the first forward path. What is the first forward path? Tell. Along the straight. First forward path is along the straight like this. First forward path along the straight. Then write that forward path again. What is that? G1, G2, G3, G4. To the first forward path, what are the loops touching? You observe. To the first forward path, what are the non-touching loops? You observe it. So what are the loops? L1 is touching. L2 also touching along the path. L3 also touching. All the three loops are touching. All the three loops are touching means no need to write any more term. All the three loops, all the loops are touching means the factor is 1. No need to write any more term. All the loops touching means the factor is 1. No need to write any more term. Plus select the second forward path. What is the second forward path? Tell. The second forward path is like this. Through G5. This is the second forward path. This is the second forward path, G5. Second forward path is G5. Second forward path is G5. G5. Okay. G5. Now listen. Second forward path G5. To the selected second forward path. Listen by all of you. To the selected second forward path, what are the loops touching? You observe. To the selected second forward path, L1 non-touching. L2 non-touching. What is touching? L3 touching. L1, L2 non-touching. Yes or no? So you have to write delta K because L1, L2 non-touching. Non-touching means you have to write delta K. Okay, you have to write delta K. Listen here. Okay, you have to write delta K. So there is no difference in writing delta and delta K. Listen all of you. There is no difference in writing delta or delta K. There is no difference in writing delta or delta K. While writing delta or delta K, we have to observe 1 minus sum of individual loops. 1 means individual loops plus sum of gain products of two non-touching loops gains minus sum of gain products of three non-touching loops plus sum of gain products of four non-touching. All these combinations we have to observe even for delta K also. You have to observe for even delta K also. All these combinations you have to observe delta as well as delta K. But while writing delta K, only difference is while writing delta K, consider the poles. When you are writing the delta K, consider the loops. Consider the loops. Consider the loops which are non-touching to the selected forward path. Which are non-touching to the selected forward path. Non-touching to the kth forward path, you can say, which are non-touching to the kth forward path. Consider the loops which are non-touching to the kth forward path. Kth forward path. You should consider the loops which are non-touching only. For example, see, to the selected second forward path, L3 touching means forget about L3. Consider only L1 and L2. To the L1 and L2, this combinations you have to write. To the L1 and L2, that you have to write all these combinations. The L1, L2 means two loops, and you have to check up to two non-touching loops. Two loops means you can check up to two non-touching loops. So you have to consider only up to two non-touching loops. So now tell, to the selected second forward path G5, L3 is touching, L1, L2 non-touching. So one more thing here. See, you observe here, for individual loop minus sign is there. Three non-touching loops also minus sign. Five non-touching also minus sign. That means take opposite sign. Take opposite sign. Opposite sign for odd number of non-touching loops. For odd, listen carefully. For odd number of non-touching loops. For odd number of non-touching loops. Odd number of non-touching loops. Next, for 2, 4, 6, there will be same sign, plus only. Plus means whatever the sign you are getting, that you have to consider. For individual 3, whatever the sign you are getting, to that opposite sign you have to take. For 2 and 4, take same sign. Take same sign. same sign for even number of non-touching loops. For even number of non-touching loops, even number of non-touching loops, even number of non-touching loops. Come on, now see, individual means opposite sign, 3 also opposite sign, 2 same sign, 4 same sign, like that. So now see, L1 and L2 non-touching to the selected forward path. Take opposite sign of individual loop, opposite sign. Minus means plus, minus means plus, opposite sign of individual loop gain. What is the loop gain? Minus H1. Opposite sign means plus H1. Opposite sign of another individual. For all the individual loops, opposite sign. What is the loop gain? Minus G3H2. Opposite sign means plus G3H2. Opposite sign of second individual loop. So individual loops are completed. Now individual loops completed. Then you have to check the two non-touching loops. Is with this L1 and L2 touching or non-touching? Non-touching. L1 and L2 is non-touching. We should check the non-touching loop gain. L1 and L2 is non-touching. So what is the sign? Same sign. Product the sign minus minus plus. Same sign you have to consider. Plus minus minus plus same sign. So plus for individual 3 you have to take opposite side. So here same sign minus minus become plus. Same sign. Come on, product it. What is the answer? What is the loop gain? G3 here H1 H2 H1 H2. So that's all. Can I write L1 L3? No, because L3 is touching to second forward path, removed already. So that's all. Divided by again 1 opposite sign of individual loop gain. For delta, all the loops you have to consider. For delta, all the loops consider. For delta K, which are the loops non-touching, that only consider. So consider all the loops. 1 opposite sign of L1 H1. Opposite sign of L2 G3 H2. Opposite sign of L3 G4 H3. Opposite sign of L3 G4 H3. Then two non-touching loops. L1 L2 touching or non-touching? Non-touching. Minus minus become plus. So G3 H1 H2 minus minus plus. So minus minus plus. So what is the loop gain? G3 H1 H2. Again L1 L3 non-touching. What is the sign? Minus minus plus. So what I will get? G4 H1 H3. G4 H1 H3. Like this you have to write it. Again L2 L3 touching. L2 L3 touching. That means that non-touching loop gain you don't get because these two are touching. Like this you have to write the directly transfer function. Okay, I'll summarize it. I hope you understood. So simply observe the forward path, observe non-touching loops. So if non-touching loops are there, 1 opposite sign of individual loop, same sign of 2 non-touching, and opposite sign of 3 non-touching loops. Like this you have to go on consider. So I'll summarize it. Okay, completed. See, I'll summarize. What I did tell? C of S by R of S equal to what I did? I selected first P1, first forward path. 1 minute. C of S by R of S equal to what I did tell? First, I selected P1. Then what I did? Observe non-touching loops to P1. Observe NTL means non-touching loops to P1. First forward path P1 means. If non-touching loops are exist, if non-touching loops are exist, then 1 plus opposite sign of individual loop. Opposite sign of individual, one I will put individual loop gains. Individual loop gains plus same sign of 2 non-touching loop gains. Same sign of 2 non-touching loop gains. gains plus opposite sign of 3 non-touching loop gains. Opposite sign of 3 non-touching loop gains plus same sign of 4 non-touching loop gains. 4 non-touching loop gains and so on. Plus again second forward path, third forward path and so on. Plus and so on. What you have to do here? Observe non-touching loops to P2. Observe non-touching loops to P2. If non-touching loops are exist, then same thing. One opposite sign of individual loop gains plus same sign of 2 non-touching loop gains. Same sign of 2 non-touching loop gains. Like this. Go on, you have to write. Opposite sign of 3 non-touching loop gains. 3 non-touching loop gains. And plus same sign of 4 non-touching loop gains. 4 non-touching loop gains. Okay. And so on. Divided by below 1 plus opposite sign of individual loop, opposite sign of individual loop gains plus same sign of 2 non-touching loop gains, same sign of 2 non-touching loop gains plus opposite loop gains plus opposite sign of 3 non-touching loop gains plus same sign of 4 non-touching loop gains and so on. That's all. So this is the what? So like this you have to write the transfer function. I hope you understood. You remember this. You can write the transfer function for any signal flow graph. One problem will solve. One more problem. Okay. One more problem will solve. Right. Find the transfer function. Find the transfer function to the given SFG, to the given signal flow graph. Right. Come on, solve it. No, this is opposite sign will take. Minus H1 , minus H2, , minus H3. Come on, get the answer. Write the answer. Come on. Just to follow this, automatically you'll get the answer. Just to follow this. Just to follow this, automatically you can write the correct answer. For example, how many loops are there here? Total 3 loops. I hope you written some, at least some students. What is the answer? Last gain is 1. Here 1 aya. This is the gain of 1. G1, G2, G3. Very good. Very good. Many students are written correct answer. Very good. Okay, listen. I'll write the answer. All of you listen. See, here we are having 3 loops. This is L1. This is L2. This is L3. 3 loops are there. We are having 3 loops. L1, L2, L3. Only one forward path along the straight. Only one forward path along the straight like this. Only one forward path and 3 loops. Now write the transfer function. Simply C of S by R of S. Only one forward path na. What is the forward path again? G1, G2, G3, G4. To this what happened? L1 touching. Here L2 touching. Here L3 touching. Along this path L1 touching. Here L2 touching. Here L3 touching. All are touching. That means no more factor. All are touching means no more factor. This when you will get non-touching loop. Observe the non-touching loop. Here there is no non-touching loops at all. That means the factor is 1. So divided by 1. Opposite sign of L1. Opposite sign of L1 tell. Opposite sign means what is the loop gain? G1, G2 minus H1. Opposite means plus G1, G2, H1. Opposite sign of L2. Bolo, what is the opposite sign? G2, G3, H2. Opposite sign means plus. So G2, G3, H2. Next, opposite sign of L3. Opposite sign of L3 tell plus. So minus means plus. So what I'll get? G3, G4, H3. G3, G4, H3. So individual loops completed. Next, 2 non-touching. L1, L2 touching. L1, L3 touching. First take L1, compare remain 2. L1, L2 touching. L1, L3 also not. L1, L3 also touching. Next L1 completed. Next L2, L3 touching. That's all. This is the answer. Very simple. Yes or no? One more problem is all this. One more problem. Come on, at least try to solve this. One more problem. Find the transfer function. Find the overall transfer function. Come on. You also draw it. Come on. Find the transfer function. Anybody answer? Actually, I am free. I can take time. I can take class even from 2 o'clock. But I think you are having class before 6 o'clock, na? Before 6 o'clock, any class you are having? Before 6, any class you are having? No? I think 1 to 5:30 class you are having. Some people are writing. Some students are having class 1 to 5:30 or 5, I think. That is the problem. That's why I control starting from 6 o'clock. College also is there. Okay. Not possible, I think. Okay. So now find the transfer function. So how many forward paths tell here? How many forward paths? 2 forward paths are there. 2 forward paths are there. The number of forward paths are 2. Forward paths are 2. How many loops? Total number of loops, how many? How many? 4 loops are there. Check it here. See, this is L1. G1, G2, H1 is a 1 loop. G2, G3, H2 is 1 loop. G4, H3 is 1 loop. And G5 like this. G5, H3 and H2 is 1 loop. This is L4. G5, H3, H2 is 1 loop. Total 4 loops are there. Now write the transfer function. C of S by R of S equal to C of S by R of S equal to, first select the first forward path. G1, G2, G3, G4. G1, G2, G3, G4, first forward path. To the selected first forward path, you observe it. Observe command L1 touching, L4 touching, here L2 also touching. Next here L3 also touching. That means all are touching. All are touching means no more term. All are touching means no more term. If non-touching is there, then you have to write, but all are touching. Now select the second forward path. Second forward path is like this. So G1 means here L1 touching, here L2 touching. Along the path L4 also touching, L4 touching. As well as here L3 also touching. That means all are touching. To the second forward path, G1 and G5 also all are touching. Divided by no more forward path, delta. What is delta? 1 opposite sign of L1. That is G1, G2, H1. Opposite sign. G1, G2 minus H1. Opposite means plus. Opposite sign of L2. That means G2, G3, H2. Opposite sign means, so G2, G3 minus means opposite sign plus H2. Next, opposite sign of L3. Opposite sign of L3 means plus G4, H3. Next, opposite sign of L4. What is L4? G5 minus H3 minus H2. Minus minus plus. Opposite means minus. Minus G5, H2, H3. G5, H2, H3. Opposite sign of L4. G5 minus H3 minus H2. Minus minus become plus. Opposite sign means plus. It is a individual loop only. Opposite sign. So plus. Here plus, opposite sign means minus. Next, 2 non-touching loops. L1, L2. L1, L2 is touching. L1 this, L2 here touching. L1, L3 non-touching. L1, L3 non-touching. Non-touching. Minus minus become plus. Minus minus become plus. So that means what is the loop gain you are getting? G1, G2, H1 as well as G3, H2. G3, H3. G3, H3. Yes or no? G1, G2, H1, not G3, G4, H3. G4, H3. G4H3, G4H3, L1, L3 not touching, L1, L4 touching. Next L2, L3 touching, L2, L4 touching, L3, L4 touching. So that's all. Like this, you have to write the transfer function. Okay, na? Okay, you take the 10 minutes break. Take the 10 minutes break. After that, I'll continue. Okay? Okay, na? Okay. 10 minutes break. I'll discuss the doubts at the end. Okay? 10 minutes break you take. Otherwise, it will be delayed. Okay. Next problem. Next problem. कर ले. Next problem. Right. Next problem. Find the transfer function, overall transfer function. Find the overall transfer function. To the given SFG. You also draw it. Come on, solve it. Write the answer. I'll give the 4 options. First, you write the answer, all of you. Tomorrow, no class, I think. Write the answer. Are you written the answer? Are you written? G1, G2, G3, G4 plus G4, G5. 1, 2, 3. Any more answers? Any more answers? Come on, come on. Okay. So write it, all of you. Write the answer. Come on, select the first forward path. Observe the non-touching loops. Select the second forward path. Observe the two forward paths are there here. Select the second forward path. Observe the non-touching loops. Divide it by delta. Come on. Okay. Right. So for example, if you give this question in the exam, for example, if you given this question in the exam, first option A, listen. Option A. Anybody generally, they'll select the one forward path. Minimum one forward path they'll select along the straight like this. And minimum they'll select the three loops because as H1, H2, H3 is clearly visible. H1, H2, H3 clearly visible, na? So this they'll take L1, this they'll take L2, this they'll take L3 minimum. Then they'll write the answer generally. Or he may take even two forward paths also. For example, one forward path only. One fellow, he selected one forward path, three loops. And a written answer is G1, G2, G3, G4 by 1 plus G1, G2, H1 plus G2, G3, H2. Opposite sign of L1, opposite sign of L2. Opposite sign of L3, G3, G4, H3. This is option A. Option B is, you tell the answer, option B is same numerator term. Numerator term as it is. Numerator term as it is in the B option. In the B option also, numerator same. Numerator same. But one more term extra. Plus one more forward path, G4, G5 plus G4, G5. Denominator, one more term extra. Denominator, these terms are same as it is. All these terms are there as it is here. Plus one more term extra. One more term extra. That is G4, G5. Minus sign here, minus G4, G5, H1, H3. Option C is same numerator. Whatever the B option is there, same numerator. And denominator is including this one more term extra, minus G2, G5, G2, G5, H1, H2. So this is option C. And option D is denominator term, numerator is same. Option D is numerator is same. Denominator, one more term extra, for example. Minus G1, G2, G3, G4, H1, H3, H1, H3, G1, G2, G4, H1, H3. So now, which is the correct answer? Which is the correct answer? Come on, you tell which is the correct answer? A, B, or C, or D? C, B, D, D. B, B, C, A. Listen here. Listen. So once you write the transfer function, after writing transfer function, don't select that is a final answer. For example, you selected only one forward path, three loops. Then you written answer. So you got option A. Then don't select directly option A is the final answer. Why? Because these terms are there in the B option, same terms are there in the C option, same terms are there in the D option. Yes or no? Same terms are there in the B, same terms are there in the C, same terms are there in the D option. So that's why don't select it. You observe these terms in how many options are there? 4 options are there. In the B option, one more term extra in the numerator. Denominator, one more term extra. If these terms are correct or wrong, you have to identify. Numerators are called forward paths. Numerators are called forward paths. Denominators are called loops. Denominators are called loops. Is it correct forward path or not? You should identify. G4, G5. Start from input. So input forward path means input to output na. So start from input. So 1. So next G5, G5 like this. G5 and G4. That means it is a correct forward path because each node touching only once. It is a correct forward path. G4, G5 is a correct forward path. Numerator is correct. Check the denominator. G4, G5, H3 and H1. It is a correct loop. Check it. It is a correct loop. It is a correct loop like this. It is a correct loop. That means this is L4. This is L4. It is L4. This is L4. It is a correct loop. It is L4. It is a correct loop. Like this. G5. Like this. G5 and G4 like this. H3 and H1 like this. This is the correct loop. Next again, and that means option B correct. Even option B, you written option B, for example, don't select that is the final answer. Why? Because same terms, whatever the terms are there in the option B, same terms are there in the C and D. Same terms are there in the C and D. C and D also having same terms. C and D having same terms. So, but only one term extra in the C. That extra term correct or not, you identify. Go along this path, identify either it is correct loop or not. Go along this path. So, for example, I'll go along this path. G2, make it dark. G2, make it dark. G2 dark. Next, G5, make it dark. So, like this. G5, make it dark. G5. Next, H1, make it dark. Like this. Next, H2, make it dark. Now, check it. G2, H1, G5, and H2. Dekho. So, G2, H1, G5, and H2. It is a correct loop. Check it. It is a correct loop. Each node touching only once. It is a correct loop. This is called L5. This is called L5. Correct loop. That means option C correct. Option B also wrong. Option B also wrong. Now option C is correct. Even you written option C, don't select that is a final answer. Observe option D, either correct or wrong. Go along this term. G1, for example, see G1, G2, G3. So already this node touched. G3, G4, H3. This node second time touching. That means it is not a correct term. So D is wrong. D is wrong. Why? Because this term, this is not a correct loop. The node touching twice. See G1, G2, this node, for example, A anukunta node. G1, G2, A is touched once. I will coming back second time touching. That means it is not a correct loop. It is not a correct loop. So that means option C correct. That means in the exam, if you practice little bit this procedure, from options itself, you can select the correct answer. First forward path, how many options is there? Second forward path, how many options is there? Loop 1, how many options? Loop 2, how many options? Loop 3. By comparing, just by comparing the answers with the signal flow graph, we can select the correct answer. But you need little bit practice. So you need little bit practice so that it will become perfect. ठीक है ना? ठीक है ना? So like this, you can solve it. Next, one more problem. One more problem. Next problem. Okay. I hope clear. Is it clear? Any doubt? Okay, better I'll discuss at the end. Otherwise, time wasted. I'll discuss it. Don't worry. So next, right. Next, find the overall transfer function. Find the overall transfer function to the given block diagram. To the given block diagram by using signal flow graph analysis. By using Mason's gain formula. By using Mason's gain formula. Mason's gain formula. R of S summing point G1 summing point G2 H2. G3 G4 this should take it H1 better. Here take H2. CFS. Come on, solve it. First, all of you draw the signal flow graph. You draw the signal flow graph to this. Then you came to know, are you able to write the correct signal flow graphs or not? Come on. All of you draw the signal flow graph. Just to draw the signal flow graph. Right. Here, to draw the signal flow graph, listen all of you. I hope you've drawn. You take another 10, 30, 1 minute time you take. Come on, draw it. Are you drawn? Are you drawn the signal flow graph? Okay, good. So now see, I will draw the signal flow graph. Each summing point you have to consider as a node. Each take-up point you have to consider as a node. The block gain should be treated as path gain. Summing point node, take-up point node, as well as the block gain should be treated as a path gain. So now input is R of S. This is R of S. Now summing point. So here nothing is there means path gain 1. So here to here path gain 1. This is 1. Next, This summing point, this summing point. What is the path again? G1. So G1 like this. Summing point consider as a take summing point consider as a node. Take up points also consider as a nodes. So up to this I draw. Next from this summing point to this take up point, path gain G2. So path gain G2. Up to this we completed. Next, after this, some students what they are doing, this, all these three they'll consider as a single node. This node, this node, this node, all these three they consider as a single node. Then automatically you'll get the wrong answer. Block diagram technique gives the different answer. Signal flow graph analysis gives the different answer. Then you are wrong. Never eliminate a single line between summing and takeoff. Don't eliminate. This is one node. This is one node. This is one node. This is one node. What is the path gain? 1. This is one node. This is one node. What is the path gain? 1. And this is one node. This is one node. What is the path gain? 1. This is the path gain 1. Never eliminate any line between summing and takeoff and summing. Don't eliminate. As it is, reproduce. Just reproduce it as it is. Don't eliminate. As it is, reproduce. Why? Because if in case eliminate, the non-touching loops are going to be touching. Actually, this loop is non-touching. If these three consider as a single node, then this loop is touching, then you will lose the marks. That's why as it is reproduced. Actually, no need to draw any signal flow graph in the exam. It is not at all required. Don't draw any signal flow graph. Don't waste the time. Directly can write the answer. Just to some students, even if I tell also, they'll draw the signal flow graph and they'll do the mistake. So in objective type, conventional, if you ask, you have to draw signal flow graph. Objective type, I am talking. So this is one node, this is one node, path gain 1. Again, this is one node, this is one node. What is the path gain? Tell G3. This is G3. Then parallel is G4. This is parallel with G4. This is G4. Next, this is one node, path gain is 1. Now this is one node, path gain is 1. This is path gain. This is here. As it is reproduced. So now tell from year to and year. Year to adopt G3 and year. What is the path gain? Minus H2. Minus H2. Minus H2. See, year to year. After the 1, year before the 1. Next, G2 directly here. Here, what is the path gain? Minus H1. Minus H1. Minus H1. Now, year to year. What is the path gain? Minus 1. Here minus is there, na? So minus 1. This is the correct signal flow graph. This is the correct signal flow graph. Don't eliminate any line between summing and takeoff and summing. Okay, na? Don't eliminate it. Don't eliminate any between summing and takeoff and summing. Any branch. Don't eliminate any branch or any line. Otherwise, you will lose the marks. Okay, na? But what is my suggestion is, you no need to draw any signal flow graph. It is not at all required. Directly we can write the answer. Can't to identify number of forward paths, tell here. Forward paths directly in block diagram, you cannot identify. You can identify number of forward paths. One forward path straight like this, G1, G2, G3. Second forward path, G1, G2 and G4. This is the second forward path. Why to draw this? Tell, wasting the time. Can't to identify loops, tell. You can identify the loops. Now, okay, first I'll take a duplicate one more. Okay, see, listen. Okay, see, forward paths. So we can identify directly forward paths. Now, how to identify forward paths? How to identify one forward path? Is straight like this. This is the straight one forward path. Second forward path straight again going to G4. Two forward paths. Why to draw signal flow graph? Tell. Why to draw? Not at all required. Loops. Take a feedback path H1. For example, this is the feedback path H1. This is the feedback path H1. To this, how many forward paths? Only G2. That means it is loop 1. to this feedback path H2. How many forward paths? One is G3, another one is G4. That means two loops, that is L2 and L3. L2 and L3. Yes or no? One loop is G3 and H2, another loop is G4 and H2. Two loops. Why to draw this? Tell. And third one, this is third feedback path. How many forward paths to this? One is G3 like this. Second one is G4 like this. That means two loops. That is L4 and L5. Yes or no? Here also we can say same thing now. Here also. This is L1. So G3 and H2 is L2. And G4 H2 is L3. And G1, G2, G3 and unity is L4. G1, G2, G4 and unity is L5. What is the logic of drawing signal flow graph? It is simply wasting the time. That's why whenever they ask objective bit, you don't draw the signal flow graph. If you ask the objective bit, don't draw the signal flow graph. Don't waste the time. Don't draw the signal flow graph. Don't waste the time. Okay, na? Don't waste the time. So directly answer. How to answer means listen. 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 So listen here. Okay, listen. First, whenever you see in any block diagram or signal flow graph, first you see in any block diagram or signal flow graph, first simplify parallel in blocks or parallel in branches. This is what parallel in. This is what parallel in branches. This is parallel in branches. Yes or no? This is what parallel in blocks. First simplify parallel in blocks or in signal flow graph means parallel in branches. First simplify parallel in blocks or parallel in branches. Okay. First simplify parallel in blocks and parallel in branches. For example, here these two are parallel in blocks. You simplify this. Simplify this. This is parallel in blocks. Now simplify. What I will get? Tell G3 plus G4. What is the advantage of simplifying means? Automatically the number of forward paths, number of loops are reduced. So whenever you see the block diagram, first simplify parallel in blocks. Simplify parallel in blocks. Parallel in blocks. Parallel in blocks is simplified. So that what happened? The number of forward paths, individual loops are reduced. Number of forward paths and loops are reduced. Now see how many forward paths? Only one forward path now, because these two become one block. That is G3 plus G4. So one forward path. There will be only one forward path. Now loops you tell G2H1 is one loop, that is L1. And these two become one block means this is only one loop, L2. G3 plus G4 into H2, one loop. And then third loop, to this also only one forward path. That means three loops. There are only three loops are there. Third loop is G1, G2, G3 and minus. So only three loops are there. So that simplification become easy. In case if you take it 5 loops and then write it, after that you have to take the again simplification. You have to take the terms common and then you have to write. Instead of that, if you simplify parallel in blocks, directly we can write the answer. So what is the answer? Tell here. C of S by R of S equal to, come on. What is the answer? Come on, what is the forward path? G1, G2 into G3 plus G4. G3 plus G4 divided by 1 opposite sign of L1. Opposite sign means G2 H1. Opposite sign of L1. So opposite sign minus G2 H1. Opposite means plus. Opposite sign of L2. Minus means plus. What is the loop gain? Tell G3 plus G4 into H2. G3 parallel na G3 plus G4 into H2. Opposite sign of L2. Next, opposite sign of L3. Opposite sign. What is the opposite sign? Minus means plus. G1, G2 into G3 plus G4. G3 plus G4. Yes or no? G1, G2 into G3 plus G4. So this is opposite sign of L3. Then non-touching loops. Non-touching loops. L1, L2 both are non-touching. Minus minus become plus. L1, L2 is non-touching. So minus minus become plus. Plus, bolo G2H1 into G3 plus G4 into H2. So this is L1, L2 non-touching. L1, L3 touching. L2, L3 touching. That's all. It is the answer. This is the answer. So like this, you have to write the answers. Okay, na? This is the transfer function. Next problem. Next problem. I hope you got it. Okay, next problem. Find the overall transfer function. To the given signal flow graph. Sorry, to the given block diagram. Come on, solve it. Before me, how to solve? You should tell the answer. Come on, solve it. Find the transfer function. This is C of S. Completed. G1, G2, G3 plus G1 for that problem. Right. Solve this problem. Come on, tell the answer. G1, G2, G3 plus G4. Very good, very good. Still check it. Chada. You check it. Terms all denominator terms you check it. All are written correct or not. Kirat Kaur Chada. Next, come on. Tell the answers. Very good. Kirtana. Good. Kirtana, check it. Denominator one term missing, I think. Nidumula Kirtana. Come on. Any more answer? Arvind, you are also check it. Numerator also one term missing. Okay, I'll write the answer. Listen, all of you. No need to draw the signal flow graph. Listen. Listen. How many loops are there here? Tell. Number of loops you tell. This is L1. This is L1. G2, H2 is L1. Next loop is G1, G2, G3 and H1. This is L2. Next third loop is, this is second loop. This is L1 like this. This is L1. Second loop G1, G2, G3. This is L2. Third loop is like this. Here started through G4, coming back like this. Again coming to like this. So this is what? This is L3. 3 loops are there. Now write the answer. C of S by R of S equal to C of S by R of S equal to first forward path G1, G2, G3. G1, G2, G3 is the first forward path. To this forward path, L1 touching, L2 touching, L3 touching. All are touching. To this forward path, L1 touching, L2 touching, L3 touching to this. L3 like this, na, here it touches, here it touches. Plus, select the second forward path, that is G4, G4. So this is the second forward path like this. To this L1 is non-touching, na. L1 is non-touching. This is the second forward path like this. L1 is non-touching. That means 1 plus G2H2. 1 plus G2H2. Divided by, there is no more forward path. Divided by, come on, 1. Opposite sign of L1. Opposite sign of L1 means plus G2H2. Opposite sign of L1 means minus means plus G2H2. Then opposite sign of L3. Come on, L2. What is opposite sign of L2? G1, G2, G3, H1. Yeah, G1, G2, G3, H1. Opposite sign of L3. What is opposite sign? G4 and H1 minus. So opposite means plus. So G4, H1. Then non-touching loops. L1, L2 touching. This is L1. This is L2 touching. But L1, L3 non-touching. Dekho, this is L1. This is L3 non-touching. Minus minus become plus. L1 G2H2. L3 G4 H1. That's all. But L2 L3 is touching because same feedback path. L2 L3 is touching. Like this you have to write the transfer function. Okay. One more problem. One more problem. Get the screenshot you want. One more problem. Last problem. After that, we'll discuss the volume 1, volume 2 questions. Next problem. Find the overall transfer function. Find the overall transfer function to the given block diagram by using Mason's gain formula. Come on, you also draw it. Come on, get the answer. First, draw the signal flow graph, all of you. Check it, are you able to draw correct signal flow graph or not? Check it, are you able to draw correct signal flow graph or not? Completed? Right. Okay, listen. Are you drawn signal flow graph? Are you drawn signal flow graph? Numerator 3 terms, denominator 5 terms. Very good. Done. Signal flow graph. Okay, I will draw it. Listen. Most of the students, this question asked for 15 marks in the IES actually. But same question in the GATE, they used to ask for 2 marks only. So listen. So how to draw signal flow graph? Listen here. First node is R of S. This is R of S. R of S. No. R of S. Then here, this is one node, this is one node, path gain is 1. Now this is one node, this is one node, path gain is 1. Here 1. This is one node, this is one node. What is the path gain? G1. This is the path gain of G1. Now this is one node, this is one node, path gain of G2. This is G2. This is one node, this is one node, path gain of G3. This is G3. This is one node, this is one node, path gain of 1. This is 1. C of S. Okay, next. H1, where it started? It started at this node. Where it is end? At this point. So G3 started and at before G3. What is the path gain? Tell minus H1. Minus H1. Now some students, they'll draw H2 like this. It is wrong. The signal, it won't come back like this. Arrow gives the signal. This is the signal direction. The direction of the signal is like this. It won't come back. No signal coming back. The same signal, whatever coming through H1, same signal passes through H2. That means second feedback path is starting here only. H1, H2 minus. That means here starting and here the path gain is minus H1, H2, H1, H2. The path gain is minus H1, H2. Third feedback path is again, don't draw like this. It is starting here only, same signal, H1, so H2 and H3. Some students H1, H2 minus sign they'll take and come back. No, wrong. That minus sign for H1, H2 only. Third one, H1 into H2 into H3 minus. So that means start here, end at this point. What is the path again? Tell. Minus of H1, H2, H3. Minus of H1, H2, H3. Then again, forward path. Here G4 up to G1. So G4 after G1 like this. This is called G4. G4. And next, don't draw like this. The signal it won't go. Same G4 coming to here as well as going to next after G2 also. Same G4 going to after G2 also. That means here also G4 only. G4. See G4 here. G4 here. So this is the correct signal flow graph. It is a correct signal flow graph. Now tell how many forward paths are there here? How many forward paths? This is one forward path. This is along this one forward path. Second forward path through G4 like this. Third forward path through G4 like this. So there are three forward paths like this. How many loops are there? How many loops? Tell. This is L1, G3, H1, one loop. G2, G3, H1, H2 is the second loop. G1, G2, G3, H1, H2 is the third loop. This is the third loop. So like this. This is the third loop. This is the third loop. Only three loops are there. Some students 5 loops they'll take. How will get 5 loops? So it is not coming back to here, na? It is coming to here only. So in some students they'll take like this. They'll come back. How can you come back, man? You cannot come back. If you come to the block diagram, in case, if you come to the block diagram, if you come to the block diagram, this is L1, this is L1, this is L1. And second loop is G2, G3, H1, H2. This is the second loop. Third loop, G1, G2, G3, and coming back to the same point. This is the third loop. Fourth loop, how can you take? Some students, they'll take like this. They'll go like this. They'll come. And how can you come back to here? This direction. Check the direction. Na? You cannot come back to this point. That means we are having only 3 loops and 3 forward paths. So what is the answer? Tell. C of S by R of S equal to 3 forward paths. So G1, G2, G3, 1 forward path. Second forward path, G4, G2, G3. Go along this, automatically will get. Third forward path, G4, G3. So to this, all are touching. First forward path, L1, L2, L3 touching. Second forward path, L1, L2, L3, all are, because all are passing through G3 only. L1 passing through G3, L2 passing through G3, L3 passing through G3. So forward paths also passing through G3. So that means all are touching. Divided by delta. 1 opposite sign of L1. So that means what? G3H1. Opposite sign of L2. So that means what? G2, G3, H1, H2. Opposite sign of L3. Come on, bolo. G1, G2, G3, H1, H2, H3. So like this, you have to write the answer. Next, non-touching. L1, L2 touching. L1, L3 touching. L3 like this only, na? Passing through L1 only. L1, L2 touching. L1, L3 also touching. So this is the answer. Like this, you have to write the transfer function. Okay. Next, come to the volume 1. I hope you solved all the questions in the volume 1. Very easy. Okay. Volume 1, first question. Question 1, I think you solved it. Simply what you have to do? You have to apply the Laplace transform. So what is the question given? They ask find transfer function. Put the all of you book, open the book, volume 1 book. So they given simply differential equation 2d square y by dt square plus, I hope you solved it, 2 dy by dt plus 4y equal to r of t plus 2 or t minus 1 given. Simply what you have to do? Apply Laplace, take it common y of s here, or simply input related terms by output related terms. So that is y of s by r of s equal to what we will get? What are the input related term? 1 plus e power minus s tau. 2 is there here. 2 e power minus s tau. 2 e power minus s tau. Tau is 1 na? E power minus s divided by 2s square plus 3s plus 4. That's all. This is the answer. So that means answer is what here? A. I think answer is A. Answer C. 2s square plus 3s plus. Both the options are same. Oh, positive sign in there. So answer C. C is correct. And I hope second question you might have solved. The impulse response of initially relaxed system is that is G of t. Initially impulse response referenced by G of t. Given as 2 into e power minus 2t given. 2t into u of t given. Then to produce the response of, so we want response of what means output given. What is the output given? 1 minus e power minus 2t into u of t given. Then what is asking? Input should be r of t, they are asking. Simply solve C of s by r of s equal to what? They didn't mention the feedback. That means it is open loop system. So G of s. What do you want? R of s you want. So that means R of s equal to what? C of s by C of s by G of s. That is nothing but Laplace of C of t divided by Laplace of G of t. Apply Laplace transform, then you will get R of s. So that means what I will get if apply Laplace here, 1 by s minus 1 by s plus 2 divided by Laplace of G of t is what? 2 by s plus 2. Then you simplify this LCM if you take s plus 2 minus 2 s plus 2 minus s divided by s into s plus 2 divided by 2 by s plus 2. So then these two cancelled, then ss cancel, then what you are getting? 2 by 2s you are getting. 2 cancel, that means 1 by s. You apply inverse Laplace transform. R of t becomes what? Apply ILT. 1 by s ILT is 1 u of t. That means answer is B. Similarly, question 3 you might have solved it. Impulse response. The unit impulse response of a unity feedback system. Output given. C of t mentioned. T e power minus t given. T e power minus t given. And the open loop transfer function equality is asking. Open loop transfer function is asking. That is G of s is asking. So that means what you have to do? The unit impulse response of a unity feedback. Basically, it is a closed loop system because feedback mentioned. Feedback mentioned means closed loop system. That means closed loop transfer function you will get. What is the closed loop transfer function? C of s by R of s equal to G of s by 1 plus G of s. That is nothing but Laplace of impulse response. A given impulse response, na? Laplace of impulse response. That equal to what? Laplace of t e power minus t. So what is the answer? 1 by s plus 1 whole square. So g by 1 plus g equal to unity feedback mentioned h of s1. So g by 1 plus g is 1 by s plus 1 square. So that means g by 1 plus g equal to 1 by s square plus 2s plus 1. How to find g? I already told. Just subtract the numerator term in the denominator. To get open loop transfer function from closed loop, subtract the numerator. That means s square plus 2s. So what is the answer? 1 by s into s plus 2 is the answer. So that means answer B. B is the answer, like that. And next question 4. Question 4, if you want, get the screenshot. Next. Question 4. Question 4. So given for the system shown in figure below, the change in G is given 10%. Then what are the percentage of changes in the open loop and closed loop systems are given? ST, first I'll take open loop system. So STG equal to percentage of change in transfer function by percentage of change in G. That equal to 1. Percentage of change in transfer function by percentage of change in G is 1. That means percentage of change in transfer function equal to percentage of change in G. Change in transfer function, change in output, both are same. Transfer function means output by input na same. How much changing in G? 10%. That means open loop system changes by 10%. Next, go for closed loop system. Closed loop system, STG equal to percentage of change in transfer function by percentage of change in G. That equal to 1 by 1 plus GH. STG for closed loop, 1 by 1 plus GH. Now percentage of change in transfer function equal to percentage of change in G by 1 plus GH. How much change in G? 10%. Divided by 1 plus G is 10. H is 1. That means 10% by 11. That means approximately 1%. Closed loop is 1%. Open loop is 10%. Next, fifth problem, I hope you can solve. Just finding closed loop transfer function, that is nothing but K G by 1 plus GH. Sensitivity solved by yourself. That is very easy. Next, sixth problem. Just what you have to find? Yes, M, K you have to find once. And next you have to find, you solve it, you will get 1 here. Next, S, M, H. SMH means what? Dou M by M divided by dou H by H. That means H by M. M means transfer function into dou M by partial derivative M with respect to H. You will get the answer. Similarly, K also you will get the answer. And next, sixth question. The amplifier with open loop gain means G given. There they put A naught. It is a open loop gain. The open loop transfer function given 2000 plus or minus 100 given. And it is required to have an amplifier overall gain. This is overall gain, overall transfer function. Variation in overall transfer function given. Percentage of change in transfer function, overall transfer function. Percentage of change in overall transfer function. Whose overall? Whose voltage gain varies not more than not more than plus or minus 5%. The percentage of change in overall transfer function is plus or minus 0.5%. Then what is the feedback factor they are asking? First you find percentage of change in G you have to find. That is nothing but dou G by G into 100%. Percentage of change in G you find. So percentage of change in G, percentage of change in transfer function 5%. Percentage of change in G you find. So change in G is 100 divided by G is 2000 into 100%. Into 100%. 2 zeros, 0, 0 cancel. That means 5%. Percentage of change in G is 5%. So now use STG formula. STG equal to percentage of change in transfer function means overall transfer function by percentage of change in G equal to 1 by 1 plus GH. Now tell percentage of change in transfer function plus or minus 5% means 0.5%. change in G 5% equal to 1 by 1 plus G is 2000 into H. Now solve this. It will become percentage cancelled. Then 0.1 equal to 1 by 1 plus 2000 H. Now solve for H. H equal to what? I think 4.5 into 10 power minus 3 you will get. I think. Correct. Next, question number 7, simple output by input na. So millimeter by per second. Next, question number 8. Question number 8, what is there? Assertion given. What is given assertion? Introduction of negative feedback in the amplifier result reduce the bandwidth. Wrong answer. Because I told in the last day, gain bandwidth product is always constant. So what happened with the feedback? Gain reduced. That means bandwidth increased. That means assertion wrong. Assertion wrong. False. Assertion wrong or false. But region is correct. Gain bandwidth product constant. Region correct, as well as it is a correct explanation. So region correct. That means assertion wrong, region correct means it is option D actually. In assertion and reasoning, first option is A and R. Both are correct. Both are correct, as well as R is correct explanation for R is correct explanation. Correct explanation for A. That is the first option. Second option is same thing. A and R both are correct. A and R both are correct only. Both are correct. But R is not a correct explanation. R is not a correct explanation of A. Correct explanation. Like this will be there. Correct explanation of A. C is A correct. A is correct. And R is wrong. R wrong. Like this will be their options. D is A wrong, R correct. R correct. That means our answer is D. R correct. Our answer is D. So like this, these are the assertion and reasoning questions. Okay. So I'll stop here. Volume 2 questions you solve. If you have any doubt, you can ask. That question only I'll solve in the volume 2. Volume 1 I have to solve in the class. Volume 2 you have to practice by yourself. If you have any doubt, you can ask. In volume 2 also I'll discuss it. Okay. I'll stop here. So if you have any doubt, you can ask. Sri Charan.
Hello.
Tell man.
Sir, page number 9, sir.
Tell.
Sir, here, what I think.
Tell.
Sorry. G1, H2. Sorry, sir. I thought H2 direction is that's it.
No. Feedback.
I thought that G1, H2, G4, H3, H1 will become a loop.
No. Direction check it now.
If H2 direction is that side.
Why you are taking that side? Then it will be changed. Our forward paths become 2.
Okay.
Okay.
Sorry, sir. Okay, sir.
Next. Akshay Kumar.
Sir, I have doubt in volume 2 actually.
Tell which question.
Sir, question number 4.
It is not audible. Question number you tell.
Question number 4.
What is there? Consider the following statements in the connection with feedback.
Yeah. Sir,
What is the
fourth
doubt
statement.
there? Feedback improve the stability or harmful? Correct only na?
Sir, first one I understood. Fourth one I didn't get.
In general, sensitivity depends on parameter variations only na?
Okay.
What is the sensitivity definition? Variation in the output due to change in system parameters.
Parameters. Okay.
Correct only na?
Yeah.
Okay
And
na?
where the feedback is located, it is also saying like location of parameters.
Actually, that word should not be there, something given.
Yeah.
System parameters, that's all.
Okay.
Okay.
Okay. Yeah.
Okay.
Thank you, sir.
Okay. Next, Srina Pasanna. Srina,
Sir, can you hear me?
tell.
Sir, I didn't receive the text, volume 1, volume 2. Which text you are, that byte and bits text you are?
Not bytes and bits. Volume 1, volume 2 books are there for each and every subject.
No, sir, that text I didn't receive.
You ask them, na? When you joined it, you should ask.
Sir, text name what now?
Control systems, volume 1.
Okay, sir. Okay, sir.
You ask them, okay, na?
Sir, one text received, control system, but it is a workbook.
That is volume 2, I think.
Okay.
Volume 1 also is there.
A textbook is there.
Textbook. Volume 1 is a textbook. Volume 2 is a workbook.
Okay, sir. Thank you, sir. Thank you.
Okay. Next, Abhinay. Hello? Abhinay? Hello? Next, Venkatesh,
Sir,
tell.
sir, once explain that 3 non-touching loops.
Huh?
3 non-touching loops.
Which page?
So it's first.
Tell.
Sir, we get L1, L5. That's it, sir.
Huh?
3. Oh.
Tell, man.
Sir, once explain this one, sir. 3 non-touching loops. How, sir?
Take L1 nodes and L5 nodes. What is the nodes of L1?
X2, X3.
Okay, gone. Tell. What is L1 node? X2, X3. What is L5 node?
X1, X4.
That's all. Now check with all the nodes. L1, L2, L3, L4. You check it. All the nodes. You check it. X2, X3, X1, X4. Check it. All are touching or not?
Yes, sir.
That's all.
Sir, but there is only L1, L5, na, sir. Again, one more loop.
Next L1, L6. 2 non-touching loops. Whatever is there, that combinations you have to check it. 2 non-touching loops. What are there? L1, L5, L1, L6, L1, L6. You have to take. Again, you have to check. Hello?
Yes, sir.
Okay, na?
Sir, we got only L1, L5. Again, one loop, sir. We should take 3 non-touching loops, na, sir.
We checked with all. Na, it is not possible with third loop. These X1, X2, X3, X4 touching with what? L1, L2, L3, L4, L5, L6, L7. How can it possible 3 non-touching? 3 non-touching loops is not possible with L1 and L5.
Okay, sir.
Okay, na? Like that you have to
Okay,
check
sir.
it. Okay?
Okay, sir.
Okay.
So once,
Tell.
sir, we taken that after break one problem you said, no, sir.
Tell what is that page number?
Sir, option A, option B, option C, correct.
Tell.
Sir, how did, sir, this loop
Verify the bookings. That's all. What is there?
G1, G5 minus H2, H1, G2,
G1.
H1. Sir, this third option, how it is correct, sir?
Go along that path, man. That loop is correct or not? Tell. G2, H1, G5, H2. Is it correct loop or not? Check it. Each node touching only once means it is a correct loop. That's all.
Sir, second one is wrong, sir. Sir, it is also correct, no, sir?
Second one is also correct. But here one loop missing, na? Actually, total how many loops? 5 loops are there. In the second option, 4 loops only written. But 5 loops you have to write, na?
Okay, sir.
Okay,
Yes,
na?
sir. Okay, sir.
All the loops you have to write.
Okay, sir. Thanks.
Next, Venkatesh. Venkatesh.
Completed, sir.
Okay. Next, Amulya. Amulya. P. Amulya.
Am I audible, sir?
Tell.
Sir, what is meant by return difference, sir?
Return difference, it is a digital control system. It is not required.
Okay.
It is removed from
That's
the
it.
syllabus.
Okay. Thank you, sir.
Next, Bhargavi.
Hello.
Tell.
Sir, today's last problem, sir. Last problem, sir.
Tell.
No, not this one, sir.
Tell.
This one, sir. Sir, can't we consider individual loops, sir? That is G2 and H2 as individual
How
loop.
can you move along the path and tell? Along the direction you move. This is the direction. This is the direction. Can you come like this? What is the
No.
direction here?
Opposite direction.
Then how can you move?
Okay, sir.
Direction important, na? Okay.
Yes, sir. Got it, sir.
Next, Shivam.
Sir,
Shivam.
volume 2, question number 6, sir.
Volume 2, question number 6. Simply, I told, na? What I told? In a closed loop control system,
Yes.
feedback network is more sensitive or forward path is more sensitive? STH is greater or STG greater?
SST means
STH, feedback network, is more sensitive than the
Yes, sir.
forward
Yes,
path
sir.
gain.
Yes, sir. Yes, sir. Yes.
What is H there?
Beta.
That's all.
Yeah.
Even if you find ST beta, that will become greater than remain STK, STA. Simple logic is feedback network is more sensitive than forward path. So beta is the answer. That's all.
Sir, any conventional method is there to solve this?
Conventional means you find closed loop transfer function.
Okay, sir.
Then you have to check all the options. STK you have to do, STA you have to check, ST beta you have to check.
With all
That
the
will become more
parameters,
lengthy, na?
means with all parameters I have to check.
You have to check it. But
Okay.
concept, you have to use the concept. Now, why unnecessary wasting the time for 1 mark bit, that is. Okay.
Hello.
Okay,
Sir,
na?
question number 12, sir.
Question number 12, that will come in the time domain analysis. By mistake printed here.
Okay,
Okay.
sir. Sir, what I did, sir, I calculated the response due to D of S, and then I calculated the
No, E
response.
of
due
S
to-
by D of S you have to find. Steady state error due to disturbance input, na?
Yes, sir. Yes, sir.
E of S by D of S you have to find out.
Okay, okay.
Okay.
It will come.
It will come. I'll discuss in the class.
Okay.
Next, Abdul.
సార్ ఇది లాస్ట్ ప్రాబ్లం చెప్పారు కదా లాస్ట్ ప్రాబ్లం
Is the last problem, is it? Tell.
సార్ మనము ఇక్కడ కింద లూప్ లో G1 G2 G4 G2 G3 లా అంటే సపరేట్ చేశారా సార్ ఒక్కొక్కటి
అంతే కదా, three loops separate కదా. This is one loop, this is second loop, this is the third loop. You check here. This is one loop, G3 H1 one loop, G2 G3 H1 H2 one loop, G1 G2 G3 H1 H2 H3 one loop.
ఇది అర్థమైంది సార్. ఇంకో ప్రాబ్లం ఇది కాదు, వేరే ప్రాబ్లం లో కింద -G1 G3 ఒక ప్రాబ్లం.
పేజ్ నెంబర్ చెప్పు.
ప్రాబ్లం చెప్తాను. పేజ్ నెంబర్ 224. ఇదే సార్.
చెప్పు.
ఇది మైనస్ ఎలా వస్తుంది సార్ ఇక్కడ?
వాట్ ఇస్ ద పాత్ గెయిన్? G5 G4 -H3 -H1 లేదా? minus become plus. Opposite sign you have to consider individual loop.
అంటే పైన ఒక డైరెక్షన్ కింద ఒక డైరెక్షన్. ఆపోజిట్ అంటే మైనస్ ఇంటూ ప్లస్.
Opposite sign of individual loop. What is the formula? 1 Opposite sign of individual loop gains. Whatever the loop gain you are getting, to that opposite sign you have to consider.
ఓకే సార్.
Okay, na?
ఇది అర్థమైంది సార్. అందుకని ఇక్కడ మైనస్ ఎందుకు వచ్చింది అంటే ఇప్పుడు ఈ మైనస్ H1 ఇది మైనస్ H2 కూడా
మైనస్ మైనస్ ఏమవుతుంది?
మైనస్
ప్లస్ అవుతుంది. ఆపోజిట్ సైన్ అంటే ఏమవుతుంది?
అపోజిట్ సైన్ మైనస్ అవుతుంది
అంతే దట్ సార్.
టోటల్.
అంతే. ఇక్కడ ప్లస్ ఎందుకు రాసినావు? వై యూ రిటర్న్ ఇయర్ ప్లస్? What is the loop gain? G3, G4 minus H3. But here plus you written why?
ఇక్కడ
Here G3, G4, H3. Why you written plus here?
ఇది నా డైరెక్షన్ మైనస్ H3 కాబట్టి మనం పాజిటివ్ తీసుకుంటాం. నెగటివ్ డైరెక్షన్.
ప్లస్ ఉన్నప్పుడు మైనస్ తీసుకోవాలా? ఓకే.
రివర్స్ డైరెక్షన్.
ఓకే. Individual loop means opposite sign you have to take.
ఓకే.
Next, Akansha.
Hello.
Tell.
So, volume 2, question number 12.
That will come later in the time domain analysis. I'll solve.
So, on question number 3.
Question number?
3.
Huh?
3, sir. 3. 1, 2, 3.
3. 3. What is there, Amma?
So, disturb means sensitive.
Sensitive to perturbation means variation.
So, it should be both now. G.
How it is both? Tell. What is STG? Tell.
1 by G. 1 plus GH.
1 by?
1 plus GH.
1 plus KGH. K is there.
Yes, KGH.
K how much given? K value how much? I gain given. Read the question.
Yes, sir. I gain.
I gain means infinity. What is the answer?
Okay. Okay.
STH how much? Minus KGH by?
1 plus KGH.
What is the answer? K infinity and 1 neglected. What is the answer? Minus 1. Highly sensitive.
Okay.
Okay, na?
Yes, sir. Thank you.
Okay. Next, Abhinay. Tell man. Any doubt? No voice, no, not audible, anything. Hello? Okay, I'll close it. Okay, it is not audible. Akansha Lal, okay na already?
Yes, sir.
Okay.